this video, we are going to talk about the higher order derivatives. So let's have first this example. So if y is equal to 3x raised to 5 minus 2x, find the fourth derivative. So we have here our derivative, which is our y, which is equal to 3x raised to 5 minus 2x. So we're going to look for the first derivative, second derivative, third derivative, until the fourth derivative. So in here, we're going to use the constant and exponent rule, where we are going to multiply this exponent to the coefficient. Okay, so we have here, so since this is 5, so we're going to multiply 5 by 3. So we have 15, and then we're using the power rule or the exponent rule, which is we're going to subtract 1 in our exponent. So since this is 5, we're going to subtract it by 1. So 5 minus 1, so we have x4. And then, what's the derivative of 2x or negative 2x? So we have negative 2. Okay, so we already have the first derivative. So let's proceed to the second derivative. So again, we're using the constant and exponent rule. So the exponent, we're going to multiply the exponent in the coefficient. So 15 times 4, so we have 60. And then we're going to use the power rule, which is 4 minus 1 or n minus 1. So we have x raised to 3. So since this is a constant, we know that the constant rule is any number that is constant is equal to, will always be equal to 0. So we just leave it there. 60x raised to 3. So we already have the second derivative. So let's proceed to the third derivative. So again, we're using the constant and exponent rule. So the exponent, we're going to multiply it by the coefficient. So 60 times 3, so we have 180. And then the power rule again, n minus 3. Our n is equal to 3, so 3 minus 1, so we have 2. So that's the third derivative for this example. And last, for the fourth derivative, so again, we're using the constant and exponent rule. So 180 times 2, so we have 360, right? And then the power rule, n minus 1, our n is equal to 2, so 2 minus 1, so we have 1, or simply we just leave it like this. Okay, so our fourth derivative is equal to 360x. So the fourth derivative of y is equal to 3x raised to 5 minus 2x is equal to 360x. Okay, so let's have another example. So we have y is equal to 2x raised to 4 minus 3x cubed plus 2x minus 5. So let's just put down here 2x4 minus 3x cubed plus 2x minus 5. So we're going to find the, let's say we have, find the fifth derivative of this problem. So we're going to find. So let's proceed in solving this problem. So in first derivative, so we're using the constant and exponent rule. So 4 times 2, so we have 8x. And then power rule, 4 minus 1, so we have 3. Then this one, derivative, so we have 3 times 3. So since we're using the constant exponent rule, 3 times 3, we have 9x. And then power rule again, 3 minus 1, so we have squared. And then derivative of 2x is equal to positive 2, right? And then since this is a constant, so it is already equal to 0. So we have the first derivative. Let's proceed to the second derivative. Again, constant and exponent rule. So 8 times 3, so we have 24x. 3 minus 1, so squared. Then 9 times 2, 18. Copy, since this will be already equal to 2 minus 1, or is equal to 1. And then, what's the derivative of 2? The derivative of 2 is equal to 0. Okay, so let's proceed to the third derivative. So again, constant and exponent rule. So we have 48x. And then, what's the derivative of 18x? Is equal to 18. So that's the third derivative. Okay, for the fourth derivative, okay, so 48x is equal to, the derivative of 48x is equal to 48. And then, since this is a constant, so this is already equal to 0. So the fifth derivative, so the fifth derivative is equal to 0. So I hope you understand this lesson. Thank you for listening and have a great day.